Okay, so we know the rules. So the first one, we have powers, and we are doing a multiply. So what do we do to the actual exponents? We will add them. So 1/2 plus 3/2. We have to add them. What do you do when you add fractions together? What's the big idea you need?
Check the denominators.
Common denominator is 2. So I can add the top. 1 plus 3 is 4 over, and then just a 2 is the common bottom. And then I'm going to go a step further. 4 divided by 2 is 2. So my final answer ends up being x to a number 2. Okay, this is the same idea. We have a multiplication, so we're going to add the exponents, but before we do that, multiplying, so this coefficient is a 6, base is an x, and then I have to figure out the exponent, and I'm going to figure that out by adding the exponents. Okay, so we have a 1/3 plus a 4/6. Okay, the bottom is not the same, so I'm going to turn it into the same number, and the number I'm going to pick is a 6. I'm going to make them both a 6. So I can turn this into a 6 by multiplying it by 2. And if I do that, I also need to multiply the top by 2, creating a 2. This is a 6, so don't change it. So then don't change it. So it stayed as a 4. So now when I add, I get a 6 over 6, which is a 1. Oh, look, I'm not even going to write it. I'm done. I'm just going to leave it. I don't need to write a little 1 there. If you did, it's not wrong, but it's not needed. Okay, one more. So this one would be 30x to the what? So I multiply, so coefficients do the regular math, powers do the power rules. So I have to do 1/3 plus 2/5. What number would you like to pick as a bottom number that they both will fit into? 15. So I'm going to pick 15 as a common denominator. So I'm going to change this to a 15 by multiplying it by 5. So then the top becomes a 5. I'm going to change this into a 15 by multiplying by 3. So that would turn into a 6. And it stays like that. Okay. All right, the next example is now division. So once we divide, we're going to subtract the exponents. So we're going to be subtracting exponents. So 5/2 minus 3/2 is what I'm going to be performing. Look at that, they're already over the same bottom. They both have a 2. So I don't change anything. So then on the top, I'm going to look at a 5, subtract 3, which is 2. That answer is just x, because it's a 1 exponent on the x. So I'm just going to leave it as just an x. Okay, next, division. So I'm going to write the coefficient 7, and I'm going to write x. And then I'm going to subtract. So 2/3 subtract 9/3. Okay, they're over the same bottom. So -7/3. What if I told you you had to rewrite that with a positive exponent?
Flip it.
I'm going to flip it. Do I flip the entire thing or just the power part? I'm actually going to leave 7 on the top because 7 is not attached to that power exponent. This is the part that has the negative exponent on it. The 7 doesn't have a negative exponent on it, so it doesn't move. Okay? Only the base exponent moves.
So, can you say that again?
So this negative exponent applies to what? The x or a 7x? Just the x. So it's the thing that moves. That negative exponent is not applying to the 7.
And we can do either answer.
Yeah, this or that, this is the same meaning in math. But if I state your answer has to be expressed with a positive exponent, then you're going to have to turn it into that, yeah. Okay, so here's another example just quickly here, because my grade 11s, actually my grade 12s have to do this quite a bit. 5x to the -3. How else would I write that? Five over x cubed. You see what the math is doing there? If I say write it with a positive exponent, that's what you would do. Okay? Versus this is different. What's the different scenario here? This would be 1 over 5x cubed. Do you see the difference in my math there? This, the exponent is only on the x, so I just moved the x part. This, the exponent is on the unit 5x, so I moved the whole thing. Okay, so that's a good foundation to understand there, because understanding numbers, this is what it's all about. What are they doing? Okay, and then the last example, let's see what we got. So division, so I'm just going to go 80 divided by 10, so 8x to the rule, subtract them. Subtract the exponents. So the bottom is not the same. What do you want to pick as a number? 3 and 4, 12? So I'm going to be timesing this unit by 4 because I would like to turn this into a 12. So then that top would turn into an 8. Okay, did you know this? When you use the exponent 1/2, it's the same math as doing a square root. Yep, so for instance, 36 to the 1/2 should equal what? 6. the exponent 1/3 in math is the same as doing the cubed root of something. So if I do 125 to the 1/3, I should get 5. Okay, so do you not believe me? Now let's see if I am making it up or if it makes sense. So 125 to the bracket 1/3, we said should be 5. And there it is. So
How would
one.
that be shown the long way?
Like that. That's it. It's just a cubed root. Okay, ready? Okay, so we have this to the 1/2. So we have to apply the 1/2 to the 16. What's the normal? It's just math. What is 16 to the 1/2? AKA, what's the square root? 4. Then, what's the power rule? What do you do with exponents to an exponent? Exponents to exponent, you times. So I'm going to be doing 4 times 1/2, which is 2. So exponents get timesed. Okay, ready? Coefficients always have the regular math. So coefficient to the 1/3. What is 27 to the 1/3? So AKA, it's the same as doing the cubed root of it. So that is a 3. And then, power rule? The exponents have to multiply. So I get 5 times 1/3, which equals 5/3. So I just am thinking as 5 as a 5 over 1. So 5 is the top, 3 is the bottom. 5/3. Just straight across, yep. Do you want me to do like another random? So what would this be, Moses?
8 over 45.
That's it, yeah. Okay, everyone remembers that as a rule? Okay, ready? Coefficients, regular math, so multiplying them. I need to do this times this. So the top is going to be 3, and the bottom is going to be 20. X to the, what do you want to do with the exponents? What do you want to do with the exponents here? What's the rule? If this is a multiply, what should they do? They add. Okay, so I'm going to go onto the sideline here. 2/3 plus 4/5. I need a bottom denominator. I'm going to pick 15. So this times is by 5, and this times is by 3. Okay, that was good. Okay, we have a couple things going on here. There's stuff with this rule and there's this rule. There's a multiplication rule and there's an exponent rule. So, what should I do because of bed mass? What should I do first? I should do this first and then do the exponent next. So the brackets inside the brackets first. So I'm going to do this first, which means, what's the rule? Multiplying, what should I do? Add. You're going to add. Okay. I need a 20. I'm going to have to add them, so I'm going to need a 20. So I'm going to times this unit by a 4, and I'm going to times this unit by a 5. 12 plus 5. And I got x to the 17 over 20. When you're done, see if you get the same. Then that's the bracket. So now we have to take it to the 2/3. I still have this yet. Remember we just did the in the bracket part. So the bracket came out to 17 over 20 with the exponent. Now to the 2/3. So now what's the next rule? I'm going to multiply. So when I multiply this, I'm going to go, what is 17 times 2? 30, what is it? 34. 20 times 3, 60. And there's my final answer. Okay. The next one, it looks really complicated, but it's very simple, and here's your answer.
Is it a 0? Like, is that,
Your answer is going to be that fast.
is that power of 0?
It's a power of 0. So what is all of this, even though it looks super complicated? What is it?
1.
Just 1. So what is 1 times that? Boom, that's it. So did you notice how I made it look really complicated? But it wasn't. Understanding anything, doesn't matter what's in here, to a 0 is 1. Okay, ready. We have to do the coefficient gets the normal math. So here's the normal math. I have to do the math on that. AKA, what is the cubed root of negative 27? What times itself again gets you to that?
9. That one is possible.
Yeah,
Negative 3.
negative 3.
Negative 3 times a negative 3 times a negative 3. Do you see the negative 27 out of that?
So it applies to just square roots,
The which does?
the cube roots.
This is a cubed root,
Yeah,
which
so
means like
the
that.
whole, it's not possible. It only applies to square roots.
The negative positive stuff? You
Yeah,
can't, yeah, you can't square root a negative, but you can cube root a negative. Is that what you mean?
Yeah.
Yep. Because does this make sense? 3 negatives would make a negative. If I ever did a 4th root,
It won't.
you won't get a negative doing that.
So all
If
numbers.
5th root, you can use negative, yep. Yeah. X to the, and the power rules. When you do exponents, those are the rules. When you do coefficients, it's just the math. So what is the rule here? multiply. Are you okay if I put this over a 1 just to keep my stuff lined up in my brain? What multiplies on the top? Negative 4 over 3. Or could you write that for me in a different way? What is a different way to write that in math that's the same? Negative 3 over x to the positive 4/3. Okay. Now, I could see this being confusing. Did some of you want to move the negative 3 because you saw a negative? It's not a negative exponent. It's a negative coefficient. There's no on this part, there's no negative exponent. So don't move it. So identify it as an exponent. It's not an exponent. There's no exponents on it.